Oh, yeah, I'm recording. All right. So again, proportional reasoning. You've done proportional reasoning a lot, probably in middle school, probably in geometry. You guys work with similar figures in geometry? Yeah, then you've done proportional reasoning. Okay. So, we're taking a look at more of the algebraic piece of it, the algebraic side of it, with some word problems associated with it. All right. So recall that a ratio. If I'm talking about specific is a ratio. A ratio is just a comparison of two numbers by division. Okay, think about the term rational number, ratio number, rational number. That means any number that can be put into a fraction or a ratio of two numbers. That's what basically a fraction is. A proportion is when you take those two ratios and set them equal to one another. You make a statement about those two ratios and say, okay, these are equivalent to one another. That means they are in proportion to one another. Okay. So a proportion is an equation stating that two ratios are equivalent. They are within the same ratio. In a proportion, the cross products are equal. This is what's called the cross products property. You see it there. The cross products of a proportion are always equal to one another. For example, if you're looking at it algebraically, I like this statement right in the bottom right here. If A over B is equal to C over D, then A times D is equal to B times C. A times D is equal to B times C. The cross products of any proportion are equivalent to one another. My Algebra 2 teacher, and I didn't hear it anywhere past that, he always called them the means are equal to the extremes. The means meaning the product of A and D, and the extremes being the product of A and C. I don't know, he like drilled that into our brains. I had not heard that after Algebra 2. So I don't know. If you ever hear that, that's what that means too. The means are equal to the extremes. The cross product of the proportion of the two ratios are equivalent to one another. Okay. So that being said, let's solve some. I've got 16 over P is equal to 24 divided by 12.9. Okay. And again, go with cross products. Don't try to look for a pattern and apply the pattern. Go for cross product. That's going to be our best route. What I mean by that is I am going to multiply, let me get a highlight here. I'm going to multiply these things together, and then I'm going to multiply those things together. Okay. So let's do that. I've got 16 times 12.9 is equal to 24 times P. 16 times 12.9 is equal to 24 P. So let's go to my calculator there. Oh, I don't know. 16 times 12.9 off the top of my head. 16 times 12.9 is 206.4. Is equal to 24P. Okay? And then to solve this equation, I just divide by 24 over to the other side. 206.4 divided by 24 gives us 8.6. 8.6 is equal to P. Questions there? Not too bad, right? Take a look at the next one. Just watch out here. The only issue is for this one, I've got an expression in the numerator rather than just a number. Well, you're still just multiplying the cross products. Product means multiply, but you're still just taking the cross products. But watch out here with this 5. You're basically going to do this. 5 times 8 minus x is equal to 2 times 3. You're going to multiply that entire numerator by that other denominator, that cross product, which means that I've got to distribute in. 5 times 8 is 40, minus 5x is 6. Looks like I'm going to get a decimal here. 6 minus 40 is going to be negative 34. I didn't even need to do that. Negative 5x is equal to negative 34. And then I divide by negative 5. Negative 34 divided by negative 34 divided by negative 5 gets us 6.8. 6.8. Makes sense, right? Good. Okay, so that's the algebraic piece of it. Let's talk about the applications of it. One of the applications is percentages. Because percents can be expressed as ratios, you can use the proportion percent over 100 is equal to part over whole. Think about the the word percent. Right? Think about the word percent. Analyze the word. Percent. You know, that cent in there, the cent, C-E-N-T, is referring to 100. Yeah, 100. Like if you think about the word centimeter, how many centimeters in a meter? 100, right? That cent is referring to 100. So this per out of 100. That's what that word really means, out of 100. So percent over 100 is equal to part over whole. That proportion will allow you to solve any percentage problem that we've had. Okay, percent over 100 is equal to part over whole. There's kind of two ways to solve a percentage problem. Either you make an equation out of it, or you make a proportion out of it. I'll show the proportion method because that's the section that we're in. A poll taken one day before an election showed that 22.5% of voters plan to vote for a certain candidate. If 1,800 voters participated in the poll, how many indicated that they planned to vote for that candidate? What was the raw score? What was the raw value of the people that said that they were going to vote for that particular candidate? Well, I could set up a proportion. I could say, yeah, on the right side there. I could set up a proportion. Again, percent over 100 is equal to part over whole. Well, I could say 22.5% as a whole number. You don't even need to put it as a decimal. Percent over 100, which is kind of, that really is kind of putting it into a decimal, isn't it? If you divide by 100, that's what moves the decimal place to units, is equal to part over whole. Well, think about it. Is 1,800 the part or the whole? It's the whole, right? Yeah, it's the whole number. If 1,800 people participated in the poll, I want to know how many decided to vote for my particular candidate. And here's my proportion that I can solve. Okay, I can take 22.5 times 1,800. I'll do the whole cross multiplying and dividing in one step. 22.5 times 1,800, and then I'm going to divide by 100, which just knocks off two zeros. 405. X is 405. So again, remember, we created X, put it back into context. How many indicated that they plan to vote for the candidate? 405 people. Well, that's like the bare minimum. You know, just label your answer, basically. If I really wanted to get particular, you'd say 405 people plan to vote for that candidate. The good old tree and shadow problem. The good old tree and shadow problem. The tree in front of Lucas' house casts a 6-foot shadow at the same time as the house casts a 22-foot shadow. 22-foot shadow. If the tree is 9 feet tall, how tall is the house? Let's get artistic, people. Okay, the tree in front, that's a tree. The tree in front of Lucas' house casts a 6-foot shadow. 6-foot shadow. Okay. At the same time, his house, blue house. Here's the door. Window. 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 Jim. Maybe they're having a fire. I guess the fire would be. All right. At the same time, the house casts a 22-foot shadow. If the tree is 9 feet tall, how tall is the house? All right, so we could set up a proportion. Aren't these similar figures? Now, if I was thinking about this geometrically, aren't these similar figures? Yeah, I could draw in a right triangle. I know I'm not exact because I'm taking it to the middle and whatever. I could draw a right triangle within each of these pictures, right? So these are similar figures, and we can assume that the angle of the sun, since it's happening at the same time, the angle of the sun is the same. So therefore, all of these angles are the same as well, right? I just need one angle out of a right triangle to be the same to have angle. right? All right, so now I know that these two shapes are similar. I can set up some proportions. So if I want to find x, what's a proportion that we could create? There's a couple that we could create. What's one proportion that we could create to solve for x if we wanted to? Oh.
You could do 9 over 6 and then x over 22.
Good. 9 over 6 is equal to x over 22. Does anybody think about it differently? Luke?
I did 6 over 22 is equal to 9 over x.
Yeah, 6 over 22 is equal to 9 over x. Anybody think about it differently? Could you also say 9 over x is equal to 6 over 22? Yeah, that's kind of the same thing as this one though, right? Flip that around. Could you also say x over 22 is equal to 9 over 6? Yeah, just make sure things are in the same ratio to one another. If I'm going to go object divided by shadow, the other side has to be object divided by shadow. If I'm going to go shadow over, small over big, the other side has to be small over big, right? So now, think about it this way. Does that change anything here in terms of the cross product? No. I'm still going to do 9 times 22 is equal to 6x. 6x is 9 times 22, right? So when I solve this, I still get 6x is equal to 9 times 22, 180, 190. Oh, geez. It's too early for this. 198. There we go. That's 198. And then when I divide by 6, we get 33. 33. So my answer is the house is 33 feet tall. Make sense? Cool. Oh yeah, we didn't. Yeah, I'm gonna leave that last problem behind. Okay, you got about 9 minutes if you want to start your homework. I'm gonna turn off the video here.